Okay, let's try it together. We know that we are given bn plus 1 equal to bn plus 1. Okay, this means that, for instance, if you are told that the first term is, let's say a1 is equal to 2, that means, sorry, b1. If you are told that the first term of the sequence b1 is 2, that means if you want to get the second term b2, it will be equal to square root of the first term b1 plus 1. Does it make sense?
Yeah.
That means the next term will be square root of 2 plus 1, which is 3. Is that clear? And then if you want to get the next one, b3, it will be equal to the square root of b2 plus 1. That will be square root of root 3 plus 1. Does it make sense? And then it follows that pattern on and on and on. And if you want to get the limits, now as n approaches infinity, I have informed you before that when you have something like this, okay, no matter the n you have here, even if it's n minus 1, n minus 2, n plus 3, n plus 4, the limit of this as n approaches infinity is the same thing as the limit of b sub n as n approaches infinity. Why? Because as n approaches infinity, n plus 1 also approaches infinity. Do you get that? Do you understand me? So no matter what you are doing to this, no matter what you are adding to it or removing from it, it still remains infinity. Okay, so that means when I take the limit of this, it should be equal to the limit of this plus this. Abi? Alright, and then both of them should be equal. So I can take the limit here. That means that I should have the limit of bn plus 1 as n approaches infinity to be equal to, by our rules of limits, I can say this is equal to the limit as n approaches infinity of b sub n plus 1. Is it making sense? Is that clear? So what would that give us? That is going to give us, so I said that the limit of this is the same as the limit of this, Abi? So I can just, let's simplify that for that. Limit of bn plus 1 as n approaches infinity is equal to the square root of the limit of b sub n as n approaches infinity, then plus 1. Abi? Limit of a constant is a constant. Alright, so I can say that I'm using L to represent this. Altogether, both of them are the same. I can use L to represent each of them, and this will give me.
Is it
not any question.
You didn't give us
A1?
this one.
So this B1?
Yeah.
No, I was just using it to explain. It's not part of the question. We don't need it for the question. I just use it to explain the meaning of this.
Okay.
Okay, so this is going to be L is equal to square root of L plus 1. Abi?
Yes, sir.
Then you square both sides. You're going to have L squared is equal to
L plus
L plus 1. You're going to have this to be L squared minus L plus 1.
Minus 1.
Okay, minus 1 is equal to 0. So what would that give you? You can't factorize? Okay. If you cannot factorize, can you use the formula method?
Yes.
N is equal to minus b. B is minus 1. Abi? Plus or minus roots b squared. That's minus 1 squared. Minus 4. A is 1. And C is minus 1. Abi? All over 2A. That's 2 times 1. That's going to be what? 1 plus or minus square root of this 1 plus 4, right?
Yes.
That's going to be 5. Then divided by 2. So that's going to be 1 plus root 5 all over 2, or 1 minus root 5 all over 2, right? So this is, just pay attention to that. Pay attention. So this is definitely going to give us a positive result. Are we together?
Yes.
It's going to give us a positive result. So this is the positive answer that we pick. So the answer should be equal to 1 plus root 5 all over 2.
Calculator will give us the answer.
Is that clear?
Yes, sir.
Sir, sorry, can we say in B blah 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 n plus 1 tend to infinity?
I didn't get you.
That one that you wrote n is tends to infinity.
This one.
Yes.
Okay, n plus 1, Abi. You want to write n plus 1?
And I'm saying, can we?
Yes, now, yes. Fine.
So we are done like this. Just remaining questions. Sir, please, there's this question of continuity
Okay.
that someone said. On greatest integer, blah blah blah.
Okay.
Study it.
Do not fear what is.
Okay, tomorrow is the exam.
Okay, this is part of your it's part of your class.
No, as
Tell me your
far.
calculator, bro.
Do see this to Asha.
I see it. So you say it about Shana bedroom.
MTH is normal.
So look at this. Determine the point of continuity of the following functions. Determine the point of continuity of the following functions. So this is part of your lecture material. You are given something like this: f of x equal to the least integer, greatest integer less than or equal to x. That's 1. You are given another one: g of x equal to x multiplied by greatest integer less than or equal to x. And finally, you are given f of x equal to greatest integer less than or equal to sine x. You are given f of x equal to greatest integer less than or equal to 1 over x. Provided that x is not 0.
Sunday free.
So you want to get their points of continuity. Okay. So I told you that when you have functions or expressions like this, it's usually fine to draw a graph so that you examine the behavior of the function and you know where it is continuous and where it is discontinuous.
Word.
So listen. So what do we mean by this greatest integer function? It simply means for x, we want to get the greatest integer less than or equal to x. Okay? So if I put in a number, let's say 2.5, what is the greatest integer less than or equal to 2.5?
2.
2. Okay. If I put in minus 1.1, what is the greatest integer less than or equal to minus 1.1?
Minus 2.
Minus 1 or minus 2? Minus 2. Minus 2. That's the greatest integer less than, are we together? Or equal to minus 2. Do you understand that? If you pick minus 1 is greater than minus 1.1. Does it make sense? You are taking it to the floor. And this is, if you take that of say 0.5, what would that give you?
0.
That is 0, yeah. So look at something now. So let's examine the behavior of this function so we know what are its points of discontinuity. Okay? So if you examine that, you're going to have something like this. So this is some x, and this is our f of x, or say y is equal to f of x. Let's examine values 1, 2, 3, 4, for instance. You may stop anywhere just to see the pattern. Minus 1, minus 2, minus 3, and this is minus 4. So we now plot the graph and see what it looks like. So when x equals to 0, greatest integer less than or equal to 0 is 0. Are we together?
Yes, boss.
So that means that this is going to be at the origin. When x is equal to 0, our function is 0. Then when you go between 1 and 0, going from 1 to 0, we are going to encounter numbers such as 0.5, 0.6, 0.7, and for any one of them, the greatest integer less than or equal to that is going to be 0. Is that clear?
Yes, sir.
So please pay attention, Look at this now. So this is going to go from this point to this point. Abi?
Yes.
But immediately you get to 1. Greatest integer less than or equal to 1 will now be 1. So that means this line does not include this point. So there will be a hole at this point.
Yes.
That's there. Meaning that this one is not included. But then the value now jumps to 1. So from this point forward, we have this value to be 1. Is this clear?
Yes, sir.
Then between 1 and 2, this is going to be, it's going to remain at 1, Abi. Yes. Then when it gets to this point, you have the hole, then it jumps to 2 at this point.
Sir,
Yeah.
I don't understand.
You were talking when I was talking.
Sorry, sir.
Between 0 and 1, what are the values you have between 0 and 1? 0.9, 0.8, 0.5, and so on and so forth. If you take the greatest integer less than or equal to that, what do you get? 0. Okay, so that means that between 0 and 1, your graph is going to be in this manner. Is that clear? Is this clear now?
Yes, sir.
Why are we putting a hole here? I'm putting a hole here to show that this line does not apply to the point 1. Is that clear? It excludes the point 1. So the definition for point 1 is this one. That's why we're actually filling up this box. Is this clear? To show you that when x equals to 1, our function is 1. Is this clear? Then if you go between 1 and 2, for all values you have between 1 and 2, the greatest integer less than or equal to it will be 1. Does it make sense? Does it make sense? So that's how you get this. And then immediately you get to 2, the value becomes 2. So that's why this is also empty and this is filled. And then if you go like that, between 2 and 3, the same thing will be repeated. This will be empty. Then from here, this goes to 3. You're going to have this to be 3 at this point. Then you fill this again. Then you move here. You have another empty stuff there. Is it clear? So it goes in that pattern and so on and so forth. Then if you consider this, between 0 and minus 1, we are considering 0 and minus 1. What will be the values you have there? Minus 0.5, minus 0.3. Greatest integer less than or equal to that is going to be minus 1. Does that make sense? That means that for any value between this and this is 0.0, you are going to have the number here to be equal to minus 1. So you see this is the point minus 1, and this is going to be this up to minus 1. Do you understand this idea? That's the same pattern that it was following from this point forward. So you'll notice the same thing here also. If you extend from this point forward, you're going to have this to be filled. This will be empty at this point, and so on and so forth. You can see already the behavior of this function. Okay? And from the behavior of the function and from your understanding of continuity, continuity means that, and now on the graph, continuity means you can draw the graph without any jump. Are we together? Without lifting a pen at any point. But here, you can see that there's no how you want to draw this graph. You will have to lift your pen anytime you encounter a natural number. Does it make sense? When you come across a whole number, an integer, you have to lift your pen, continue here, go on, lift your pen again, continue here, go on. That means that this function is discontinuous for every integer value. Does it make sense?
Yes.
For every integer value, the function is discontinuous. So can you give this a try? The second one. Can you give it a try? I want you to give it a try, everybody. Yeah. Try to draw a graph. I want to see a graph now. Oh shit! This is meant to be one of the topics you have mastered already, have you?
Max.
Because yesterday she was saying she doesn't want to know partial derivatives.
I did not say I don't want to know it.
You said you cannot
I
know
left
it.
before you got. I did not ask you. Leave me alone.
That's good. Jesus. Wow.
Let's cut our road.
Which fed that when we that want to stop my eye. My eye I want to. It's not discontinuous.
It is not discontinuous.
That's my own thoughts. No, it's 5 1 as 1 20. I'm going to take it down.
Think about it.
Oh,
Think about it.
shit. No negative numbers. So maybe to go to 1. To go to 1. I say it's not discontinuous.
Let's give it a try. So if you try it for, look at something now. You try it for, we just want to find a general behavior. So say this is x, this is y equal to f of x, and then you put in x. Let's say x equal to 1, x equal to 2, x equal to 3, 1, 2, minus, and 3. So if x equals to 0, what is going to happen? What's going to happen to this? That's 0, right?
Yes.
So you have 0 here. So if you are going between this and this, what are you going to get? This here is always going to be 0, Abi?
Yes.
So this also will remain 0, okay? Up to this point. Is that clear? To remain 0 up to this point. Does it make sense? Okay, that's for that. Then from this point forward, our greatest integer less than or equal to x is now 1. Abi?
Yes.
And then you have to multiply by this value. Are we together? So that means that, listen very well, listen. That means when you are at this point, it is going to be 1 times 1. Abi?
Yes.
So you are going to have something like this here. Something like this here. You're going to fill this. Then that's going to be 1. 1 times 1 will be 1. Then when you are going forward, let's say you have 1.5. 1.5 is going to be 1 times 1.5. Is that clear?
Yes.
1.9 will be 1 times 1.9. So you are going to have a uniform slope. All together.
Yes.
And then it is going to be increasing towards 2. So let's say this is 2 here. This thing is going to be increasing towards 2. Does it make sense? To have a uniform slope like this. Is it clear?
Yes.
And then you are going to have the value here. You don't know what this value is going to be. But when x is equal to 2, what are you going to get? You're going to get this thing here to be 2. Then 2 multiplied by 2, that will be 4. So this is going to jump. Is that clear? It is going to jump from this 2 that it is going to jump to 4. You're going to have something like this here from this point. You're going to have this here. Okay? Then when it jumps to 4, that means that from that point forward, you will have a uniform increase, but the slope is now 2. Do you understand what I just said?
Yes.
Between 2 and 3, everything you have there will be 2 multiplied by x, 2 multiplied by x, 2 multiplied by x. Why? Because the modulus of x remains 2. Do you understand that? In that interval. So you are going to have the same, you are going to have a similar behavior, a slope. Just that in this case the slope is now higher. Do you understand me? You are multiplying each of them by 2. So this is going to go up like this. So that by the time you get to this point, you are very close to 6. Is it making sense? So you are going to have a jump. This one jumped here. This one went from 1 to 2. This one has to go from 4 to 6. So you're going to have a higher slope. Does it make sense? Do you understand this? Do you understand this thing? So it is obvious. It is also discontinuous at every integer. So there's always going to be a jump. The only difference is that they are not going to have horizontal lines except between 0 and 1. For every other point, you are going to have the slope increasing at every point. Do you understand me? Yes. So there's always going to be a jump, then the slope will be increasing as you go. So that is that about that. Alright? That's that about number 2. So it is continuous at every point except when x is an integer. The same applies to this. Alright? So let's consider sine x. So think about sine x. What would be the behavior of the greatest integer less than or equal to sine x?
1.
So you know that sine x is always between minus 1 and 1. Abi? So draw the graph. If it is between minus 1 and 1, at what point will that be? At what point will there be jump in value when you evaluate it? Do you understand me?
I told you to jump.
So don't conclude that way. Look at something. We do know that Sine 0 is 0, right?
Yes.
So at x equal to 0, you know, we are expecting a behavior like this for our sine. Am I correct?
Yes. No.
It should be up.
Yes.
We expect something like this, right?
Yes, sir.
So this is going to become 1. Everything here is just going to be under this. This here is going to be minus 1. This is going to be 1. Does that make sense?
Yes.
Okay, so if you draw this graph and you want to get the behavior of this, don't forget that this is going to be 90, which is pi over 2. This is going to be 180, which is pi. And then this is going to be 270, which is 3 pi over 2. This is going to be 2 pi. Do you understand that?
Yes,
Just
sir.
for you to understand the pattern. So you will now ask yourself that, now between 0 and pi over 2, between 0 and pi over 2, you're going to have this thing to lie between 0 and 1. Abi?
Yes.
So if it lies between 0 and 1, and you take the, you take the greatest integer less than or equal to that, it is going to go from this point, Abi, to this point. Is that clear?
Yes, sir.
Because it will remain 0 all through this interval. Is that making sense?
Yes, sir.
Then, between this point and this point, it is also going to be between 1 and 0. Abi?
Yes.
The only difference is that when x is pi over 2, this thing will become 1. So there will be a point here. Does that make sense? There will be a hole here. There will be a point here. Then immediately it leaves pi over 2. It becomes a number between 0 and 1 again. Then you have to come here and continue this graph again. So you continue like that, okay, up to and including this point. And then between this point and this point, it goes between 0 and minus 1. When you go between 0 and minus 1, what is going to happen? This is going to be minus 1, Abi? So you are going to have the value to be this. Does it make sense? Do you understand that? You are flooring it between 0 and minus 1. If you take the floor function for any value between 0 and minus 1, it's going to give you minus 1. That's why this will go like this. Do you get that? Do you understand that? And then if you are going between this, so listen now, if you are going between this one and this is still going to be a number between 0 and minus 1. Is that clear?
Yeah.
So the floor function, when you floor this, is still going to be this. Just that at this point, it will become 0. So we're going to have this here. And then the pattern repeats itself like that. Does that make sense?
Yes.
Okay, so where is it discontinuous? Where are the points where it is discontinuous?
Pi over 2.
It's going to be discontinuous at pi over 2. Abi? At pi.
Then 2 pi.
What else? 2 pi.
Yes.
So what can you say about that?
One more. Now we can say about it. Pi over 2. Then pi.
You know that you want to consider it for all real numbers. Do you understand what I'm saying? You want to consider it for all real numbers.
Yes.
So what we have done here, we have to generalize it. So what we have gotten here is for between 0 and 2 pi. All together, we know that the pattern will be repeated going forward. Is that clear?
Yes.
Okay, so we're going to say that the we'll say that, look at this now, we'll say that this sine x is discontinuous at, so we know every multiple of 2 pi. So we can say that 2 pi n, is that clear?
Yes.
Okay, n is an integer altogether. If n is 0, this will be 0. Does it make sense? It will be discontinuous at 2 pi n. Okay, that's this point. Is that clear? Then you are going to have, it is going to be discontinuous at this plus pi over 2. Is it making sense? Then it's going to be discontinuous at 2 pi n plus pi over 2. Then what else? It's going to be discontinuous at this. Is this clear? At this point. So that will be then 2 pi n plus pi. Then it is is going to be discontinuous again as 2 pi. So that's already captured by this. So we now say for all n, in this case, n being an integer. So that is that about that. Do you understand this idea? So this captures all possible numbers, real numbers you can have. So if n is 0, this is going to be 0, pi over 2, and pi. Is that clear? Which is the situation we have considered here. If n is 1, it will apply for 2 pi plus pi over 2, which will be the next cycle after the one we considered. Okay. Do you guys get it? Okay. Don't overeat your brain, please.
Don't give up. Sir, still in it. We'll see on the group chat.
Let's move on, please. Let's move on.
No,
Oh, my bed cannot take it.
you said you leave those.
No next threshold reached.
So let's take some questions on limits before we leave. Let's do some questions on limits before we leave. We are done with everything now. So just go and revise it to refresh your memory.
Okay, you first.
Which of the following series diverges?
That long something.
I just want to go fast.
Can we share?
This 2018, 2019 exam.
Yeah. It's me.
Which of the following series diverges? A.
Percy, what's the equation of the tangents using partial derivative?
Minus f over y. Minus fx over y.
You didn't do it, don't bother about it.
Tangent is written.
No, equation of tangents and normals to curves. You are meant to consider it under partial derivative.
But I didn't see it.
Lecturer did
Not touch it.
So don't bother about it.
Tangents.
It's a different situation, yeah. What you have done in 100 level is for when you have curves. Here you want to talk about surfaces, tangents and normals to surfaces. That's
You didn't touch it now, man.
so you didn't do it, don't bother about it.
Don't go and feel your like we know the material now.
So look at this. We are given which of the following series diverges n equals to 1 to infinity of 2 over 3 to the power n, b n equal to 1 to infinity of root n over n, c n equal to 1 to infinity of 1 over n squared, then d n equal to 1 to infinity of 1 over 2 raised to the power n, and then e n equal to 1 to infinity of n over n plus 1 factorial. Which of them diverges? Which of them diverges? So if you already understood what we have done, you may not. If you already understood what we have done, you may not solve anything, you may not speak your answer.